G'day everyone, welcome to your first homework video. Section 1.1 is just a review of algebra, so this certainly won't take us too long. We'll just have a quick run through some terminology and what you're looking forward to in this first exercise. So the important thing there, you can see obviously there's some definitions: term, coefficient, expression and equation. If you want to have a good practice and make sure you fully understand those, when I get to the right part, you'll be able to see down here, those education perfect terms and definitions, that's a good place to practice. Making sure that you fully understand the difference between a term, an expression, an equation, and what it is. Put simply, a term is just an algebraic collection of letters and numbers. Coefficient, the easiest way to think about it is a number in front of an algebraic term, a number in front of letters. So in this case, the coefficient of x squared would be -3. An expression is just a collection of algebraic symbols. It could be just a term on its own, or they could be added together, as you can see in that one there. This one here is a quotient, x plus 3 divided by 2, same thing. An equation, two equivalent expressions. X equals 5, that's an equation. X squared plus 2x equals -4, another equation. Obviously the key feature of an equation, the equal sign, makes it pretty easy. Next we've got, how do we actually evaluate expressions? By substituting in values. They've given you an example there. They had the expression 3x squared minus y all divided by 2. So if x is -2, they replace the x with -2, and y was 4, so they replace where y was in the expression with 4. Even though it's not needed in that case, I would probably, when I'm substituting, use brackets every time I put a number in place of a letter, just to make sure that I don't get caught out with positives and negatives. In that one there, it's clearly not needed, so you could get away without doing it, but that's just how I'd do it, to make sure I was getting it right. Then they've continued, -2, when I square it, two negatives make a positive, so that became 4, so 3 by 4 is 12, -4 is 8, all divided by 2 is 4. That's how they got the number at the bottom there. Like terms, anyone who's had me in year 8 or 9, I think I called this the year 9 golden rule of algebra. Might be new for the other teachers, it's my own little terminology there. But what it's saying is, like terms are terms with exactly the same pronumeral form. They might be written in a different order. So for instance, here we've got a squared b, here we've got b times a squared, but they're really exactly the same. Two a's and a b being multiplied together. So if I have 6 of them and I subtract one of them, I have 5 of them left over. So what was that golden rule of algebra? In any algebraic expression, you can only add or subtract like terms, that is, terms with exactly the same pronumeral form. If you're in my class, I'll be testing you on it. Make sure you know it. Symbols for multiplication and division, this is just a little minor thing. Usually we don't bother writing them. We don't write 7 multiplied by x divided by y. A number next to a letter implies multiplication. Similarly, the division sign gets a bit cumbersome. We put a vinculum and write it as division using the fraction symbol. Much easier. Last couple of things in this chapter, things you're all familiar with. Distributive law, you can see a multiplied by b plus c. How did they get that expression? Everything in front of the bracket, oh, that arrow missed by a little bit, multiplies everything inside the bracket. So a times b gave me ab, and a times c, ac. The next one, 2 times x, that was where the 2x came from. 2 by 7, 14. Got to be a little bit careful with your positives and negatives. You can check out the last two and make sure they work for you. But again, pretty straightforward. Factorization, writing expressions as the product of factors. Factors are things that multiply to give something else. So, we've all done prime factorization. 15 is 3 times 5. Factorising 3x minus 12, how did they get the expression on the right? Well, they just simply looked for the highest common factor. The biggest number that went into 3 and 12 was indeed 3. The first term had an x. The second term didn't, so 3 was my highest common factor. Put the highest common factor in front, put the leftover factors inside the brackets. Now I've got a product of factors there, so that is fully factorised. The same one down the bottom there, you can see 3, 6 and 9. The greatest common factor of 3, 6 and 9 is 3. X squared y, x, y and x, they all have x as a common factor, so that's why 3x was the greatest common factor. The remaining factors for each term go inside the brackets. Lastly, not a big focus in year 10, but with grade 11 and 12 maths coming up, you've a fair chance of doing some group theory. So we want to be able to understand some of our general properties or rules in mathematics. Associativity means associate with someone means to hang out with them. Who do you associate with? Who are your associates? Who do you hang out with? Here they're using brackets to represent association. So whether I associate B with C or A with B, as long as they're all being multiplied, I get the equivalent answer. A simple example might be 2 times 3 times 4 is the same as 2 times 3 multiplied by 4. You can see on the left I'll have 2 by 12 is 24, and on the right I've got 6 by 4 is 24. That's an example of associativity. Commutativity, you've probably heard of the morning commute, where you go to and from, to work, and afternoon commute where you head home. Commutativity means changing the order in which you do things, going from one to another or from the second one back to the first one, doesn't change the order. Again, multiplication, A times B is the same as B times A, 3 times 5 is the same as 5 times 3. Note that it doesn't work for division and subtraction. They're exceptions. They are not commutative operators. And identity. The identity just means when you apply that operation, you end up with the same thing that you already started with. So if you take an integer and multiply it by 1, you end up with the same integer. And that's what that first example is. A multiplied by 1 equals A. Similarly, the additive identity, if I'm adding a number, if I add 0, I still end up with whatever I started with. 17 plus 0 is 17. Pi plus 0 is pi. Negative root 3 plus 0 is negative root 3. So the multiplicative identity is 1. The additive identity is 0. And finally, an inverse. An inverse is the operator, is the number that when I use the operator, it gets me back to the identity element. So if A is multiplied by 1 divided by A, I get back to the multiplicative identity of 1. If it's A and I'm doing addition, the inverse is negative A. So the opposite of adding A is to subtract A. The opposite of multiplying by A is to divide by A. That's pretty much what they're getting at there, and that's an example of an inverse. Again, the terms and definitions will help you consolidate that and just make sure you stay on top of those. So when you hear those terms again, they're just a little bit more familiar. The algebra review, basic collecting like terms, adding, subtracting, substituting, pretty straightforward, as is the hot maths tasks. So your job, you've watched the video, go ahead and do the hot maths task, the diagnostic test there that your teacher will have set for you, and then get on to Education Perfect and have a look and see if you can have a go at those questions as well. Good luck. See you next time.